Hi everyone. So today we will solve this problem product of array except self. Okay, so the input is that we are provided with an array called nums and we have to generate a output array called answer. And each element of answer, that is answer I, will be equal to the product of all the elements of nums array except nums of I. Okay, what does that mean? So if you see, this is the nums array and this is the output array. Suppose we want to generate the third position of the output, right? How we will get this? So basically what we have to do, we have to multiply each and every element of this nums, okay, except the position, except the number at position number 3. So at 3 in nums we have 3. So we will multiply 1, 2 and 4. We will skip 3, right? So what we will get? We will get 8. So that is what we got over here, 8, right? So this is it. And some conditions which we need to remember is that the algorithm should be of big of n time, and we do not have to use any division operation, because there is one more way to solve this problem using division, where what we can do is, the simple way to explain it, that suppose we multiply these elements, right? What we will get? We will get 24. And if I want to find the first position, or like what will be the value at the first position in output, I can simply divide it by 1. We will get 24. Then if I want to get the output at the second position here, I will divide 24 by 2. We will get 12. Similarly, for the third position, we will divide 24 by 3. We will get 8. So this is how we can solve this problem using division operation, but we don't have to use it. We are provided with this nums array 1, 2, 3, 4, and let's assume that before index number 0 we have a value 1, and after index number 3 we have value 1. Okay, so this assumption will be helpful later. Okay, to solve this problem we will be creating prefix and suffix array. So let's define what the prefix and suffix array is. So prefix I is equals to product of all elements in nums. Nums is the input array. Product of all elements in nums before nums of I. That means if suppose this is the num array and I have 1, 2, 3, 4, then prefix of 3 will be equals to what? Product of all the elements before nums of 3. Okay, so nums of 3 is this. So product of these elements, 3, 2, 1, right? It is 6. Okay. And for suffix, similar definition, product of all element in nums after nums of I. So suffix of 2 is equals to what? Product of all the elements after nums of 2. So nums of 2 is this. So all the element after this is 4. That's it. So value of suffix 2 will be 4. So we have to first, calculate this prefix and suffix array 0, 1, 2, 3, 0, 1, 2, 3. So prefix of 0, that means all the elements before nums of I. Nums of I, where I is equals to 0 right now. So all the elements before index number 0. So that's why we took this assumption, right? Before index number 0, there is 1. So since there is 1, we will simply store 1 over here. Okay. And then when we will move to index number 1, all the elements before nums of 1. So basically multiplication of all the elements, right? So we will multiply 1 and 1, it will be 1. Okay. Then for index number 2 in prefix, we have to skip this index number 2 in nums and we have to multiply all the elements before it. That is 2, 1 and 1. So we will get 2, right? Similarly for 3, we will get 3 into 2 into 1 into 1. This is 6. Okay. Now for suffix, what we have to do, at index number 0, we will keep all the elements. We will keep the product of all the elements in nums after nums 0. So after nums 0, we have 2, 3 and 4 and 1. So we will have 4, 3 are 12, 12, 2 are 24. So we will get 24 over here, right? Then for the first position, suffix 1, it will be 12, right? 3 and 4 and 1. Then for 2, it will be 4. And for 3, all the elements after nums of I. After nums of I, we have 1. So we will have 1. Okay, so that's why we took this assumption that there is one element, there is 1 before 0 and there is 1 after index number 3. So this is it. Now we have created our prefix and suffix array. Now to generate the output, we just have to multiply prefix and suffix and their corresponding elements. So this is the output. So we will multiply these two elements, these two elements, these two elements and these two elements. We will get 24, 12, 8 and 6. Now you must be wondering how this solution is working. Let's look at the concept. What is the actual concept here? So if you notice, the prefix of I, we are multiplying with suffix of I. If we have to find output of I, what we want to do is we want to avoid nums of I and we want to multiply all the elements before it, before nums of I, and we want to multiply all the element after nums of I. So if we are doing prefix of I multiplied with suffix of I, so what does this mean? Prefix of I. Let's suppose a value of I is 2 for now. This is 2. This will be 2. This will be 2. Right? And what does prefix of 2 means? It means, let's create the nums array. 0, 1, 2, 3. And for suffix also, let's create this nums. 0, 1, 2, 3. So prefix of 2 basically means product of all the elements before nums of 2. Nums of 2 is this. So all the elements before nums of 2. This is the product. So basically prefix of 2 will contain the product of these elements. And suffix of 2 means product of all the elements after nums of 2, which is this part, right? Suffix 2 is this. So if you notice, we are multiplying this part with this part. What we are not multiplying with? We are not multiplying with nums of 2. This is what we wanted, right? If output of 2 basically means we multiply all the elements before 2, index number 2, and we multiply all the elements after index number 2, right? So this is what we are doing. That's why this prefix and suffix will generate the correct output. Okay, so this is how we solve it. Let's code this solution. So this is the code, and if you see here, we are declaring our output vector, and here we are declaring prefix and suffix, and we are initializing both prefix and suffix with 1. Why? Because we know that the first and the last element of prefix and suffix will be 1. Okay, here we are running a loop from index number 1 till the end of the prefix and calculating the value of the each index, right? If you notice, we are starting from index number 1 because prefix 0 already contains 1, right? And if you see this closely, prefix of I is equals to prefix of I minus 1 multiplied by nums of I minus 1. So how did we get this? So we know prefix of I, right? Prefix of I is basically it will store the product of all the elements after nums of I. So all the elements after nums of I are I minus 1, nums I minus 2, I minus 3, right? And product of them will be stored in prefix of I. Similarly, I can say prefix of I minus 1 will contain the product of nums of I minus 2 multiplied by nums of I minus 3 and so on. So now if you see, this part of the product is same. So we can replace prefix I minus 1, right? We can replace this part with prefix of I minus 1. So we get prefix of I is equals to nums of I minus 1 multiplied by prefix of I minus 1. Okay, so this is how we will create the prefix array. Now, similarly, for the suffix array, we will begin from the second last element because we know that the last element will always be 1. So we will begin from the second last element and we will go towards the index number 0. And then again, if you see this formula, it is similar to prefix of I. It is similar to prefix of I, right? So how did we get it? We can simply look at on the right hand side. If you see, suffix of I basically means it will store the product of all the elements after nums of I. So after nums of I, we will have nums of I plus 1, I plus 2, I plus 3 and so on. And similarly, we can say suffix of I plus 1 will contain the product of all the element except nums of I plus 1. So it will contain product of nums of I plus 2 and I plus 3 and so on. If you see this part and this part, both are same. So we can replace this part with suffix of I plus 1. So we get this formula, right? So this is how we have written it over here. So now till here, now we have calculated prefix and suffix, and we know to generate the final answer output, we will multiply the corresponding element of prefix and suffix and we will store it in output. So this is what we are doing, simply running the loop, and we are storing output I with the product of prefix I and suffix I, and then we can simply return the value output. Okay, so this is the code, and you can see the complexity is simply big of n. We are simply traversing the prefix, suffix and the output vector. Okay, so complexity is big of n, and we did not use any division operation here. So this satisfies the question's condition, correct? Thanks everyone for watching this video. Bye and take care.